What is gravitational potential? The amount of work that an external agent has to do to bring an object of unit mass from an infinite distance to a point in the gravitational field is called the gravitational potential of that point. At an infinite distance, that is, where there is no gravitational field, the gravitational potential is taken to be zero. When an object of unit mass is brought from there to a point in the gravitational field, the work performed is always due to the gravitational force. Since the work performed by the force is negative, the gravitational potential is also negative. That is, the gravitational force is always a force of attraction, so the gravitational potential at any point in the gravitational field is negative. The symbol we use to represent the gravitational potential is capital V. Measurement of the gravitational potential. Let's assume an object of unit mass, moving freely toward an object of mass capital M. Here the object of unit mass is attracted by M, and moves toward it by a small distance dr. This displacement dr is the result of work W, exerted by the gravitational field generated by M. So dW is equal to F.dr. Now, we also know from the definition of the gravitational field, the gravitational force due to the object of mass m on a unit mass at a distance of r from its center, F is equal to gm by r square. So from equation number 1 and 2, we get the work done dW is equal to gm by r squared. Dr. Now, to bring the unit mass from infinity to a position r, the work done, or the gravitational potential V, is equal to the integral to infinite to r of dW, or integral to infinite to r of gm by r square. Dr. Now solving this equation we get V is equal to minus gm by r. This is the measure of the gravitational potential. The relation between gravitational potential and gravitational field. The gravitational potential V is equal to the integral of E.dr, or E is equal to dV, dr. This is the relation between gravitational field and gravitational potential. Gravitational potential is a scalar quantity, because it has only magnitude, no direction, just like work. Unit of gravitational potential. From the definition, we find that the gravitational potential is equal to the work done to bring an object from infinity, divided by the mass of the object. So the unit of the gravitational potential is equal to the unit of work, divided by the unit of mass. Therefore the SI unit of gravitational potential is joule per kg. And the CGS unit of gravitational potential is erg per gram. If you enjoy our videos, then don't forget to like, share, and subscribe.